when A and B is being positive or being negative at the same time, you need to flip, and you need to flip the inequality sign. But if either side is positive or negative, which means that one side positive, one side negative, or vice versa, then you don't have to flip the sign. Let's do some math for fun. Today we are still going to solve the same rational quadratic inequality, but this time we are using different method. Now here's the thing. 1 over x squared minus 2x plus 1 is going to be bigger than or equal to 1 over x squared plus 3x plus 2. Now if you guys solved in the previous video, then I will show you guys what is the second solution. Now if you guys didn't watch, please be sure to watch, because this is the second question about rational inequality, and it was super hard, not gonna lie. And in this video we are going to show you another method. Now here's the thing. 1 over x squared minus 2x plus 1 is bigger than or equal to 1 over x squared plus 3x plus 2. Now, wouldn't it be nice if we just simply flip the thing, flip the whole inequality? Because if we flip, right, then we get x squared minus 2x plus 1 and x squared plus 3x plus 2, and then whether the inequality sign is going to be bigger than or equal to or less than or equal to whatever, and then we are going to just simply solve this. Isn't it really nice? So in this video I will show you guys what something called multiplicative inverse. So what is multiplicative inverse? Now multiplicative inverse is basically another property of inequality, but it depends on certain situation. So multiplicative inverse. Now multiplicative inverse is like you just flip, but you need to be careful because it depends. So now let's say you have A is less than B. Now the first thing is, if A is positive, B is positive, then 1 over A is bigger than 1 over B, or you have bigger than or equal to sign, it's still the same, you just flip. The second case is, if A is bigger than 0, B is less than 0, then you don't have to flip the sign, you're just going to flip it. The third case is, if A is less than 0, B is bigger than 0, you still the same, you don't need to flip the sign. If A is less than 0, B is less than 0, now if A is negative, B is negative, then 1 over A is bigger than 1 over B. You need to change the sign. So basically what is going on right here is, when A and B is being positive or being negative at the same time, you need to flip, and you need to flip the inequality sign. But if either side is positive or negative, which means that one side positive, one side negative, or vice versa, then you don't have to flip the sign. So that's how we use the multiplicative inverse. So let's apply this. Multiplicative inverse to here. So now let's do the first case, which means this and this is going to be positive. So 1 over x squared minus 2x plus 1 is going to be bigger than 0, and 1 over x squared plus 3x plus 2 is going to be bigger than 0, then x squared minus 2x plus 1 is going to be less than or equal to x squared plus 3x plus 2. And here's the thing. Now, we still can solve the inequality easy, right? Because what this thing say is what does this thing say is we have to make sure that this must be positive and this must be positive. So in order this fraction, this rational function has to be positive, the bottom part must be positive because the 1 is already positive. Now our job is going to make this positive. So in order to solve this, x squared minus 2x plus 1 must be bigger than 0, and then x squared plus 3x plus 2 must be bigger than 0, and then the third one is when this and this bigger than 0, which means that this and this will be bigger than 0, and because of that, when we flip, the inequality sign is going to be flipped, and then look at what we have here. The x squared cancel out. So what we have is, and then after we do some algebra simplification, I will get 5x plus 1 is bigger than or equal to 0. And now here's the thing. When I plug in a value of x that satisfies a certain range, when I'm plugging into here, I have to make sure it's positive. And then I use the same value of x, plug it to here, I have to still make sure that it's positive. And because of this, I have to make sure that the value of x must also satisfy this. Because when the value of x satisfies both of these inequality, we can guarantee that when we flip, we can change the inequality sign. Which means that I need to solve the system of inequality of these three. Because when I plug the value of x, when this bigger than 0, which means that this is going to be bigger than 0, and we flip both of them at the same time, the inequality is going to be flipped. Which means that our result after we flip the expression, the value of x still going to satisfy this. You must think like logically. So let's solve this now. This is very easy. So this is just x must be bigger than or equal to 1 negative 1 over 5. And what about here? We are just going to plot the graph. So I have y, I have x, and then we are going to plot the parabola using the roots. So our roots is negative 2, negative 1, and then something like this. And then we are going to define the region above the x-axis for here, which is this and this. So x must be less than negative 2 and x must be bigger than negative 1. For this, now as we can see, this is same as x plus x minus 1 bracket square. So our parabola is going to be something like this. Then we are going to define the curve above the x-axis. So for here it is going to be x must be less than 1 and x must be bigger than 1. And then if we plot the number line, so negative 2, negative 1, and then negative 1 over 5 and 1. And then the first one is x must be like this. This is the first range. This is the first range. The second range is x must be less than negative 2, and x must be bigger than negative 1. The third case is x must be bigger than negative 1 over 5. And then we are going to solve this system of inequality by define the overlapping region. So the overlapping region is here and here. So our final answer is x must be, and I forgot one thing again. Yeah, I always forgot this. So this is our answer for the first case, which is this. Now, before I'm moving on to the second case, let's talk about the third and fourth case, which is this and this. Now, when a is less than 0, now when one thing, let's say a, where is the a? The a is here. And a, we have to make sure it's less than 0. Does that possible? No, right? Because x squared minus 2x plus 1 is going to be bigger than 0, bigger than or equal to 0 for all the value of x. Which means we don't have any curve below the x-axis. Which means the range of x is undefined. And just as I say, we need to solve the system of inequality of this, and the result after we flip. So since this is undefined, when 1 over x squared minus 2x plus 1 is less than 0, the range is undefined, which meaning that we have no range that will satisfy, then we can just abandon it. Don't waste your time to do more work unless you are curious, you want to explore whether your theory is correct. So now let's do the second case. The second case is still the same. Now, a is bigger than 0, and when a is bigger than 0 and b is less than 0, which means that when 1 over x squared minus 2x plus 1 is bigger than 0, and 1 over x squared plus 3x plus 2 must be less than 0, meaning that x squared minus 2x plus 1 must be bigger than or equal to x squared plus 3x plus 2. So in order to make this fraction positive, x squared minus 2x plus 1 has to be positive. In order to make this negative, x squared plus 3x plus 2 must be negative. And then the third one is, now look at here, this and this cancel out. Do some algebra, you get 5x plus 1 is less than or equal to 0. And then we are going to solve this, and we need to define the region below the curve. So for this is x is going to be less than 1 and x must be going to be bigger than 1. And the second case is x must be in between negative 2 and negative 1. The third case is x must be bigger than or equal to negative 1 over 5. Right, sorry, it should be less than or equal to. So we are going to plot the number line. Negative 2, negative 1, negative 1 over 5, and 1. X must be less than 1 or bigger than 1. X must be in between negative 2 and 1. X must be in between less than or equal to negative 1 over 5. And our overlapping region is here, right? So for this, it is going to be that x must be in between negative 2 and 1 over 5, and then combining the result that we will get the final answer, which is negative, sorry, this should be negative 1. X must be in between negative 2 and -1, or x must be in between -1/5 and 1, and x must be bigger than 1. We still got the same answer, which is happy face. We get the exact same result despite the method is, although the method is different, but we still get the same answer. So this is a very good thing. When you do math, you are going sometimes to explore, discover more things, and this is our final answer. Even though the method is different, but we still get the same answer. That is very cool. This is very cool about mathematics. And as always, if you guys enjoy this video, leave a like and subscribe to my channel for more upcoming math videos. And if possible, I will make some crazy math videos like this. And I will see you guys next time.